Prob. Prob.
Hey, Mike.
Can you hear us good?
I can. Can you?
Oh, yeah, you sound good. Hey, I was going to tell you that I'll be sending you, like, the roll sheet on, it'll probably be Monday sometime. That's okay?
Sure.
Yeah, because I think, like all the dropping and adding stops, surely to God it's this weekend. So we should be pretty close at that point.
Okay.
Hey, I got another question. On Tuesday, like, how many people did you have signed in streaming? You got a thought?
I didn't take roll, but I had a roll generated, so when I get that down, I can tell you. Probably about 20 to 25, if I had to guess.
Yeah, so that's not bad. We're expecting 30-some. So who's generating your rolls?
Anthony did, just because I didn't take roll. I didn't know that when you kind of caught me off guard when you had me throw the roll around here the last minute, because I was just not thinking we were going to do roll until next week.
Yeah, no, that's cool.
I'd
like to know up front because, I have to report your attendance.
Yes, I forgot completely about that. So he generated the roll for me, and I just got to transfer it to a roll sheet, and then I can put it in the computer.
Okay. Hey, you might just want to have him generate those rolls for that streaming all semester, man.
Well, I thought about that, but each time they log out and log back in, it puts their name in. So I got to go through and mark and figure out how many times this person, if they get kicked out or if they have trouble with audio or video and they go out and come back in. So it showed 40-some people on the roll, but a lot of times there was 3 people, 3 names of the same person on that list. I'd rather just take the roll from WebEx than to...
No, however you want to do it, man. All right, thanks.
Thank you. Oh, Mike, one other thing I need to tell you.
Yes, sir.
On Thursday night, starting tonight, I have a class I'm going to be getting up and running at 6 o'clock right next door. And so if I'm not here, I've gotten one of the students, if something happens and I'm over there getting that room going, they're going to run over and get me for anything. So there'll be a few times tonight that I won't be in the room, that I'll be next door getting that class launched, and then be with that class after this class ends.
I got you. No problem. Yeah. Somebody there will talk to me. It's okay.
Just want you to be aware of that, though. That's going to be every Thursday night. I'm going to be doing 2 classrooms on Thursday nights.
So you're doing Brown Hall 133 also then?
Yes, sir.
All right. Yeah, no, that's no problem. We'll work it out, bud. Thanks.
But it shouldn't affect anything. I'll be over here the majority of the time after we get things going good over there. But tonight I'm going to be over there a little longer just because it's the first night and it's a new setup from somebody from Abingdon coming in over there. So.
Is that like a 6 to 8:50 class one time a week?
Yes, it is.
Yeah. Okay. No problem, bud.
Okay.
So the first thing tonight is I promised the folks here in Kingsport when I had the math lab hours, I'd give you those. Now look, this is good for you folks that are in Johnson City, if you're in the Kingsport, or you guys that are streaming. Remember, this is room 220 down the hall. And so what I've got here is there's Monday from 2:30 to 4:30. Tuesday, 12:30 to 6. Wednesday, 2 to 5. Thursday, 3:30 to 6. And then Fridays, they're here from 9 to 2:30. For you folks that's actually in the room, I'm going to post it on the board back here. All right. The nice thing about the folks that are there to help you is I taught them. So that's kind of helpful. It's not like you're going to hear them telling you something different than what you hear here because, again, I taught them. Like I said, that's for you folks here. If you folks in Johnson City, like I said, if you come there in this area, you can go there, streamers. I told you I'd post them, and I got them, and I got them. Now, the last thing we had looked at together on Tuesday, I think the last thing I wrote up was like the definition of the distribution of a variable. Remember, the distribution always tells me two things. It tells me what variables, what values the variable can actually take. And then the second thing it always tells you is how often it takes those values, right? That's what a distribution is. So here's where I want to start. And what you'll notice we're going to do here, what we do, it depends on the type of variable we have. And I want to start with categorical. Remember, the ones that put you in a category, or if you like a group. And remember, this chapter is about graphs, so there's like two graphs here. There's a bar graph or a pie chart. I'm like a bar graph kind of guy. You know, if you give me some kind of categorical variable and you tell me to make a graph for you that shows its distribution, I'm going to make a bar graph for you. That's just the way I am. All right? Now, here's the thing. If you're looking at a categorical variable and you want to talk about its distribution, right? So, if we're looking at the distribution here, of some categorical variable, what's going to happen is it's going to come to you and there's going to be two things it's going to tell you. It's going to give you a list of the categories. Because remember, that's what a categorical variable does, right? It puts you in a category. So one of the things about the distribution of that categorical variable, it'll give you a list of the categories. Somehow it's going to give you a list, right? It might be in a table. Hell, it might be just written out for you. And the second thing is, it's going to give you one of two things. It's either going to give you a count or percent of individuals in each category. So in other words, I'm describing how you're going to be given a distribution of a categorical variable. What you're going to see is you're going to see a list of the categories, and then one or two or maybe both things. It'll give you the count of the number of individuals that fell in each one of the categories. It'll give you the percent out of the total, right? That's the deal. So what I'm thinking is, the way I want to attack this is, I'm on the bottom of page 16 in your book here, and it's going to talk to you about this exploratory data. I want to set the semester up for you for at least the first month or so. The way our book is laid out is like this. The first three chapters are like one collection. What the first three chapters is about is you have some collection of individuals, and then you have a single variable we're going to talk about, right? So we're going to try to describe the distribution of a single variable, and that's going to happen throughout the first 3 chapters. And then we stop, and then we go to chapters 4, 5, and 6, and what happens is you have a collection of individuals, and you have 2 variables. And we're interested in, are these 2 variables related or not? So those 3 chapters are kind of like a chunk. All 6 chapters together is what we're trying to do, is we're trying to explore the data. So then we need to give you some tools, right? So in this first 2 chapters, let's do it like that. The first 2 chapters, we want to talk about exploring data. I'm still not done with categorical yet. Okay? And so what we do is, we talk about, we're going to do the following. I want to look at a single variable. And then I want to, this is chapters 1 through 3. Then we want to look at a pair of variables. That's chapters 4 through 6. I'm just writing down what I said to start with here. And then the second thing is, we always start with graphs. I know it seems weird in a math class you start with graphs, so you start with graphs. That's always the first step. Okay? And then the second step is you're going to add numerical summaries. This is where the math comes in and the calculations. Okay? So here's what I think about this. This is like chapter 1, and this is chapter 2 for us here. Well, it's also going to be when I start looking at pairs, right? So you're going to see me in chapter 1, we're making graphs. In chapter 4, I'm going to make a graph. In chapter 2, I'm going to do calculations. And in chapter 5, I'm going to do calculations when I'm looking at pairs. That's the way we're going to attack it. What I want you to remember is nobody's going to ask you about, do you know the first 3 chapters are about a single variable and the next 3 chapters are about a pair. What I want you to know is we always start by making graphs, and then we start adding our calculations to that. And the catch is this. The whole time we're working here in chapters 1 through 3, we're always trying to describe the distribution of a variable. All right? So I would like to start with the categorical, and to be honest with you, I want to look at this example 1.2 here. Because there's not much to say about a categorical variable here. So example 1.2, and I'm on page 17, it says, approximately 1.5 million full-time first-year students enrolled in colleges and universities in 2015. Do you know what they're giving you there? They're giving you your set of individuals, right? It's 1.5 million first-year students enrolled in colleges and universities in the year 2015. Those are my individuals, right? That's one piece of my data set here. It says, what do they plan to study? There's your variable. I'm going to do it like this. For major, right? That's the variable. Is that categorical or quantitative? You know, you major in English, you major in math, you major in biology, you major in business, right? That's categorical, right? This is definitely a categorical variable. Asking you for what your major is definitely putting you in a group. Okay? And then so it says here. Here are the data, and they give me a nice little table here on the percents of first-year students who plan to major in several discipline areas. Now here's the thing. Does anybody understand why they're not telling me to count? There's 1.5 million, right? I mean, there could be like 1.5 million, like 100,000 or so. So the numbers are too freaking big, so we give you the percentage. Now, that's also the percentages out of the total, right? So in other words, somewhere along the line, somebody knew how many people majored in arts and humanities, and then they divided by the total number to get that percentage of 10.1, yes? You see that table right there? That table is called a relative frequency table. You're not going to find that anywhere in your textbook. How do I know it's a relative frequency table? Because they're giving me, the first column is giving me the list of the categories, and the second column is giving me the percentages that fell in each one of those. If they had given me the counts instead of the percentages, that would be a frequency table. All right? Again, nobody's going to ask you about that either. I just want you to know that. My question is when I look at this table here, and the first column being the categories, and the second column being the percents, is this showing you the distribution? What did I tell you we had to see the distribution of the categorical variable? I needed a list of the categories and either the count or percent of individuals in each category. That table is doing that for you. The table is actually showing you the distribution, right? The first column is the list of categories, and the second column is the percent that fell in each one. Now, here's another little thing about this table. If you have your textbook, what you're going to see is that if you add all the percents up, they add to 99.8. And also notice at the bottom there's another. Is anybody bothered by me telling you that everybody that we're talking about here is supposed to be in that table, but the percentage is only added to 99.8? What should it have added to? If life was good, it'd add to 100. So what's the problem here? Oh no, this is round off error. If you was getting 92, I'd tell you something was screwed up, right? If I was getting 107, I'd tell you something was screwed up. But you're getting 99.8 or 100.1 or 99.9, I'm telling you, my problem is I just rounded everything off to the 10th position, and when I added them all up, then, I'm off by 2. Yeah, no, that's just round off error. Don't freak out about that, okay? Now, the kind of graph we want to make here is, I'm a bar graph guy, right? Now, I can stand here and tell you when you make a bar graph, two things have to happen if we're operating by hand. And me and you are never going to operate by hand, okay? But I wanted to do this much for you. When I look at that, what I see is there's a horizontal axis and there is a vertical, right? All right, I'm a math guy. That's the X and that's the Y, yes? So that's just like me drawing, okay, there's my horizontal, there's my vertical. What you're going to see when you see a bar graph is, down here would be the major. In other words, on the x-axis or the horizontal axis is going to go the categorical variable in the different categories, right? And then on the y is going to go either the count or the percent, depending on what is given to you. And in this case, what's given to you is percent. Okay? Now, if I look at my little table here, and I look at the percents, I see the smallest percent is 2.7, and the largest one is 14.9, right? So I know if I go from 0 through, I've covered all the percentages I'm looking at there, right? And I'm going to go by 5. Why am I going to go by 5? My shit counts really good by 5s. 0, 5, 10, 15, and so on and so forth. And then so what happens on the x-axis, the vertical here, where the major, your categorical variable is, you got to put your categories. And so you see arts and humanities, I'm going to write that as AH. You see where it says biological sciences? I'm sorry if you're majoring in biological sciences, but I'm going to write BS. So I apologize over. And then for biology, or excuse me, for business, I would write B. And then I would continue. Yes? And then how do we show this bar graph of this categorical variable? Well, you look at arts and humanities, and I see there's 10.1. So I come up here, and I put a little line where it looks like 10.1 is. Am I going to be exact? No, hell, I'm doing this by hand. And then I make myself a bar, right? If I'm looking at the biological sciences, I see 14.9, and 14.9, well, obviously that's a little less than 15. You notice the bars are separated. They're separated on purpose because each one of those is its own little separate category. If I was doing it by hand, I'd make sure all the bars were exactly the same width, because what do I want my eyes to focus in on is because the height is telling me how many. Right? I can look at this and say, oh, arts and humanities have a little over 10%, the biological sciences has a little less than 15. And then I would continue. Okay? So while we're standing here and talking, I'm going to do this because we need to get right to the point anyway. Remember I showed you this the other night. If you're at home and you want to start, do that little gold app out, whether you're using a PC or whether you're using a Mac, I'm going to log in here and see if I can show you how to make our first bar graph. So when I log in here, I get rid of that. Our software is under the math software. I click once. We want Minitab 18. I click once. Part of this will work for you, right? Okay. And then I do connect. Now, I'm going to give you a little heads up here. Depending on the browser you're using, and I'm using Internet Explorer, I know some of you will use it. Maybe nobody uses Explorer anymore. Maybe you use Firefox. What do you use? Google? Yeah, so the way I'm doing this, I went right to there, right? But if you're using Google, it came up and asked you for your credentials again. In other words, it asked you for your username and password. Now, you'll notice when I logged in, I only used the username out of my email address, right? But when you're doing Google and it asks you for your credentials again, you better put in @etsu.edu or it gives you a bad answer. And then when you click connect, you'll come here and you click OK. I'm trying to remember what happened with Firefox, and I don't think it does anything crazy like that. It's awful when I got to know all the browsers. But, that's part of the deal. So remember, that's when I told you the other night that Minitab was up and running, correct? And then so we have downloaded all the Minitab files out of Sapling Learning. We've downloaded those to our desktop. And then I'm going to go to File, Open. And then the thing is to find your desktop here. And you notice there's other stuff here other than this PC. There's this quick access. There's these three things, right? So I want this PC. And I need to find the C drive on my home computer, on this computer, whatever computer you're sitting at. And it's always the one that says C on whatever the computer name is, and you've named your computer house something, right? And so I choose that one, and I double-click it. And then I have to find, look, if there was a shortcut to any of this, I would have given it to you. There's not. I come down here and I find users. I double-click that, and then I got to find my username, right? Whatever your username is, and there I am. Now, right here, we're looking at this computer that's under this desk, and if I go to Desktop, Minitab, I don't care about the Mac stuff, because when you download it, you get the Mac stuff and the PC stuff, Minitab, and I'm double-clicking every time here, Chapter 1. And I warned you, EG meant examples, EX meant exercises. This is example 1.2. If you'll also notice in your textbook, when you get one and you're looking at it, even if you're using the ebook, next to that problem, there's a little thing that says data, and it gives you the name of the file, right? And it says majors. Yes? On the right-hand side there, right where it says example 1.2, out in the margin on the right, it says majors. I see example 1.2, majors. This has got to be it. If I double-click, it's going to ask me, do you want to really do that? Do you really want to put it in there? Yes, I do. Now, I was making a big deal about what was in that table. That's the table that's in your textbook there. Notice the first column is the categories, and the second column is the percent, right? And so we would like to make a bar graph. All right? So we come up here, and we go to Graph, Bar Chart, Bar Graph, right? I click OK. Now, there's a drop-down menu here. And there's three choices under that drop-down menu. And every time you go in there, it's always on the top one. Count of unique values. Now, I'm going to give you this as an explanation. Me and you is only going to use that one time the whole semester, and it's going to be when we do the capstone project. Because counts of unique values means you have the raw data. In other words, what we would be looking at here in this example, if I had the raw data, I would have a big-ass spreadsheet. There would be 1.5 million students, and I'd have their major listed. I'd have the raw data, right? I don't have the raw data here. I actually have data that's summarized for me. Yes? I know exactly what percentage fell on each one. So what I have is, I have values from a table. Anytime you're doing any of these problems out of the book, and you have a table like this, where you have a list of the categories, the percent of the count, it's always values from a table. Okay? So I click OK, and then I got all kinds of choices here, but I just want a nice simple bar graph like the textbook would have. And then it says, so look, this is how Minitab operates. To get you started, it's a drop-down menu. Then as you go, Windows opens up and asks you things. At this point, it wants to know where are things at in this little spreadsheet at the bottom here. And it says graph variable. What it wants to know is what column is your percent or your count in. Well, it only gives me one option, and it's in column 2, and it says percent. Now, can you type over there? Yes. But if you'll just see my cursor, if you'll double click, it puts it over there for me. So it knows that's what's going to be the heights of your bars. And then it says, where's the categorical variable? What it's asking you for is what column are the categories or the groups in. And notice, it's the discipline or the major. It's in column 1. I double click that. Now, normally, if I didn't have percentages already, I'd be making a big deal about making the bar heights percentages. I don't have to worry about that here. If I click OK, please. Oh, we want the software. Shit, this looks way better than I was doing by hand, and it's way faster. Right? So what I have here is, notice the major of the disciplines on the x-axis, the percentage on the y, the heights of the bars are telling me the percent that fell on each one of the different majors, right? Each one of the different disciplines. Okay? Everybody okay with that part? Now, I got a thought here. So if I give you a homework problem, you having it here is only half the battle. You got to be able to get it out and get it somewhere where you can make a copy of it or print it out or however you're going to do it, right? Whether you're going to put it in a Word document. And what I normally do is, we're going to see how this works for all of us here. I'm going to show you this too. I need Word. Maybe. Word. And I'm just going to give myself a blank one here. All right? Maybe. I want a blank one. So that's just a blank Word document there, right? And the reason I'm showing you this is because some of you will do the homework in a Word document. Some of you are going to just print it out and do whatever you're going to do with it, but you need it somewhere that you can print it out. So my thought is this. I'm going to come back to Minitab, right? If I'm using a PC, this would be my move. I come here, and I got my cursor on the graph. I'm going to right-click. You see where it says Send Graph to Microsoft Word? I can do that, or I'm going to copy the graph. I'm going to give you a couple options here, right? If I copy the graph, and I come over here to my Word document, I need to paste it in. Now here's the warning. I need to go up here under Paste, and I need to do Paste Special. I need to do that, Device Independent Bitmap, and I need to click OK. Why is that? Because if I didn't do that, and I just hit Paste, you see it doesn't have the labels. Everybody follow? We need the label. And so I'm going to show you that one more time. There was nothing special about how I did this over here. I was just in Minitab, and I had my cursor on it, and I right-clicked, and I copied the graph. All right? When I did that, I came over here, and I said, I got my blinking cursor. I went to Paste Special, Device Independent Bitmap, OK, and I get all my labels. I get the x-axis labeled, I get the y-axis labeled, and so on and so forth. Everybody OK with that? All right? That's one way to do this. If you are a Mac user, it's two-finger touch, copy graph, and then you can paste it in a Word document, and you don't have to worry about any of that stuff, at least on mine at the house this morning. Okay? All right? Let's say you don't want to do it like that. I like to give you options. If if I come here and I right click and I tell it to send the graph to Microsoft Word. In other words, it actually opened Word up, open a blank sheet up, and then put the graph in there, and notice the titles are already there. That might be a better way. Look, not only do I want to show you the software to start with and how you make a bar graph or whatever, but I want to show you how to get this shit out, because if you can't get this shit out, we're wasting our time. All right? That's how you get it out. Okay? And then I'm gonna kind of leave this here. Because here's my thing. Okay, so this is a bar graph, and it's supposed to be showing you the distribution of the categorical variable or discipline or major, doesn't it? Does it show you what values the variable can take? Yes, it does. That's what's along the x-axis here, right? Those are the different categories. Does it show you how often it takes those values? Yes, it does. That's the heights of the bars, right? The heights of the bars will tell me how many fell in each one of the different majors or disciplines. Are we okay with that thought? Yeah? So then somebody's going to come along and ask you at some point in this semester, they're going to ask you, what do you see? In other words, the thing showing you the distribution, you're looking at the distribution of that categorical variable, and they're going to know, what do you see here? Well, what I see is the whole bunch of bars. No, that's not it. What you want to tell people is, what is the most frequent major here? Which one has the highest percentage of individuals in there? It is biological sciences, right? It has the tallest bar. Which one has the least amount of majors? I'm going to say it's pretty close, but it looks to me like it's physical sciences, right? Look, I'm going to cheat. As long as I'm in Minitab, if I put my cursor there, it's going to tell me what that bar is. That bar is 2.7%, right? If I'm over here, and I'm thinking that one's close, that's 4.2. Now, the smallest one is 2.7, right? Which is physical science. Now, you see how I can do that in Minitab? When that's over in Word, it's just going to laugh at you because it just took a picture. It won't add these little bonus things in. Everybody okay with that? So they always want to know that. Okay, you're looking at a bar graph. What do you see? Well, one possibility is to tell them which one is the most popular, the most frequent, or which one is the least popular or the least frequent. Heights of the bars. One other thing I got to show you here. I'm going to get rid of this. I want to make you another bar graph. Bar chart, right? Remember, values from a table. I click OK. All this is good, and I want to go here to chart options. So then the question is, can I reorder the bars? You know this is default. If I do increasing Y, what do you think happens? What do I see? I see the bars go from smallest to largest. Did I change anything other than what it looked like? Can I rearrange them the other way? Can I go from the largest to the smallest? Am I going to change what you're going to tell me about it? No. The least frequent is still physical sciences. The most frequent is still biological sciences. Yes? Okay. That's the deal. I wanted to show you that I can reorder. Normally I don't care about reordering. I just wanted to show you that because I have something else on my mind when we get to quantitative variables, that I can order these bars in this bar graph any way you want, and I'm not going to change what I'm going to tell you about it. The most frequent is the most frequent, the least frequent is the least frequent. Right? Okay? Now, our other guy here, and I'll come back to this in a moment, is the pie chart. Now, the reason I had starred bar graph earlier is I can always make a bar graph, whether I have like 100% of the data or not, I can make a bar graph. But the catch about a pie chart, you can't always make a pie chart. We need 100% of the data. Another way to think about it is you need parts. The reason I'm saying this to you, All right, it's just one way here we're looking at majors. All right, I'll come right back here. But if you look at my little table here, right, this little guy here that's in your book, you see that very last one, other? If it wasn't there, could I still make a bar graph? Could I make a pie chart? Would I have parts of the whole? Would I have 100% of the data? And the answer is no. I need to have that other there to actually make myself a pie chart. Yes? So that's the way I want to think about it. I can always make a bar graph when you give me categorical variables. I can't always make a pie chart. In this case, if that other was gone, I couldn't make a pie chart. I can make one now because I got parts of the whole because they put that other in there. Sometimes when people ask you about a categorical variable, sometimes the individuals that's in your data set could have chosen more than one category. You know, like, in other words, okay, what kind of technology do you use? Do you use an iPad, an iPhone, the internet, a computer? You could choose more than one there, right? Would we have parts of the whole then? No, you would have more than 100% of the data then, right? And you couldn't make a pie chart, but you could make a bar graph. I'm going to come back here and I'm going to star this because this is kind of important. You need to think about it as parts of the whole. You need 100%. You can't have 115%. You can't have 85%. You need 100% or up to round off there. Okay? Well, with this majors, we do because of the other category. So if I come over here, let's see if I can do this. Under graph, right under bar chart, there's a pie chart. Right? I might as well show you that because definitely I'm not going to make that one by hand. And notice, a little different window opens up. Chart of unique values from a table. It wants to know where's the categorical variable, where are your categories. Remember that is discipline. Where's the summary? In other words, where's the percents or the counts? And then we're going to click OK. Right? So it's the same kind of setup. A little different order, but same setup. So there's your pie chart. And it's the same one that's in your textbook here on page 18. Notice they've got the different colors, and then there's a little legend on the right here that tells you, look, the blue are humanities, the dark red there is the biological sciences. We got them all, right? So let me ask you this. When you're looking at this, what do you see? When somebody's showing you a pie chart and they ask you what you see about the distribution of categorical variable, which category has the largest chunk of the pie? I'm pretty sure it's going to be biological sciences, right? Which category has the smallest chunk of the pie? That's your physical sciences, right? Look, I changed the graph on you. Hell, I didn't change the distribution. Whether I'm showing it to you in a bar graph or whether I'm showing it to you in a pie chart, the least frequent and the most frequent are going to be exactly the same. Everybody agree? Now, can I improve on this guy here? Yeah. I got to go back. I'm going to show you again. Pie chart. I would choose chart values from the table. The categorical variable, where are the categories, which column? Summary variable, where are the percent for the count? And then I would go to pie options. Maybe labels. I wanted to talk about slice labels. In other words, it was kind of hard to read the way I had it. I'm going to back up. I'm here. I'm going to go to labels. And I'm going to choose the slices, right? The little chunks of the pie. And I'd like to put on there, I'll give them all to you. Category name, the frequency. Actually, I'm going to give you this percent. And then draw a line from the label to the slice. So what does that change for me? Makes the shit a little easier to read. Right, now I can see that Arts and Humanities is 10.1, the Biological Sciences is 14.9. I didn't really change what you're seeing, I'm just telling you it's a little easier to read like that. Okay? I'm not a big pie chart kind of guy. I'm a bar graph kind of guy. I wanted to show you the software as we go. That stops me from sitting here and having to tell you, how did they come up with those being the right size of the chunk of the pie? I don't want to go into that at all. Okay? That's not what this class is about. I can sit here and take the next half an hour and show you how they came up with that, but that's not what we're interested in. What I'm interested in is somebody gives you that. And then we ask you, okay, looking at that, what percentage of the majors are social sciences? Can everybody read 10.8? I know, I'm asking you really dumb, stupid questions. I know, right? Can everybody see that the largest chunk of the pie is the biological sciences? Yeah, that's the 14.9. Can everybody see that the smallest chunk of the pie is physical sciences, which is the 2.7? Yep. If I asked you, okay, what percentage of the students majored in arts and humanities? Everybody see that it's 10.7? Can you read that? That's what I'm worried about. Not the fact that you're going to make it. We're going to make it there. We're not going to make it by hand. Okay? Now, I'm going to kind of leave that here. I don't know what we're going to get to next here, but I'm going to remind you of this. The pie chart, that's chunks of the pie, right? You've got to have 100% of the data or parts of the whole, right? Parts of the total. For the bar graph, you can make it anytime. You give me any categorical variable you want. I don't care if you got 100%, 150% of the data, 50% of the data. It doesn't make any difference. I can make you a bar graph. Okay? Now, I would like to say that there was more to talk about with the categorical variable than what I just said for the last 20 minutes, but there's not. Somebody gives me a variable, categorical. It's going to come to you in a table, hopefully. One of the columns is going to list your categories, and the other column, there might be two, they may give you the count, the percent, they may give you both. Then, depending on whether you're looking at parts of the whole and 100% of the data, you can always make a bar graph. You can only make a pie chart when you have 100% or parts of the whole. Now, I guess I could come over here and we could find ourselves a homework problem just to show you how the homework problems work here, that I'm going to work them just the same way I did the examples. It says, I'm looking on page 120, and it's one of these apply your knowledge problems, and I'm looking at .5, never on Sunday. Bursts are not, as you might think, evenly distributed across the days of the week from Sunday through Saturday. Here, the average number of babies born on each day of the week in 2014. If you're looking, what you'll notice is the table. The first column is the days of the week, and the second column is actually the average number of children born on that day. And you can see that the two fewest days are Saturdays and Sundays, right? And the other ones are, oh hell, the other ones are about the same, right? Monday through Friday. It says, present these data in a well-labeled bar graph. Okay, let's see if we can come over here. I'm looking at exercise 1.5. I got to find that file. Open. Obviously, since I've already been in here, it's going to come right back and take me to where I'm in chapter 1. I don't want example 1.5. I want exercise, which is titled burst. I'm going to double click. Click OK. And what you'll notice is that's the exact same table that's on page 21. Right? So I want to make a bar graph. It asks me for a bar graph here. Graph, bar chart. Please remember, if you don't remember values from a table, when the data's in the table, your shit looks bad. And you'll know because it doesn't look like anything mean you've seen in class. Right? Simple. Okay. I'm looking at verse, and then the categorical variable is going to be the day, and I'm going to click OK. All right, so we went from Saturday, Sunday. Remember, I still had that thing stuck where I was going smallest to largest, right? It says, would it also be correct to make a pie chart? Suggest some reasons why there are fewer bursts on weekends. First off, can I make a pie chart here? I don't have 100% of the total? In a sense, I do, right? Remember, it's the average number on every day. What happens if I try? I'm sorry, I already had things up, right? So I want, remember I've got values from the table. The categorical variable is what's the categories, it's the day of the week. What's the summary variable, where's the counts, or the average count here is verse, and I'm going to click OK. Remember I had all those nice labels and stuff? In a sense, I do have parts of the whole because I'm looking at these averages here, right? I got 100% of the data as far as I'm concerned for the 7 days of the week. Yeah? So I'm kind of curious about the last part here. Suggest some possible reasons why there are fewer births on weekends. Oh, hell, I'm open for suggestions. Oh no, she's going to give me you're going to give me the exact right answer. Because does the doctor want to come in on a Saturday or Sunday? No, we're going to schedule and we're going to be Monday through Friday, right? Doing our yeah. No, but that's actually the answer everybody's thinking is. Obviously it can't be due to the lady having the baby. No, the doctor he's going to schedule that Monday through Friday, right? He's not going to come in on the weekends. Yeah, that's actually the answer the book's looking for here too. All right, are we okay? Okay, now. That's my only options for categorical variable. All right? So then we have to move on to, what's my other type of variable? Yeah, quantitative. And I have a few options here. But we're going to go one at a time with quantitative variables. And the most common one people are used to seeing here is something called a histogram. All right, that's the most common one to show everybody the distribution of a quantitative variable. I have a question for you. On Tuesday, I gave you two definitions. I gave you categorical definition. I gave you quantitative definition. What makes a variable quantitative? I'm going to give you first off, it better be a number. Right? The values better be numbers. What was the second thing? It better makes sense to do some kind of mathematical calculation with, like, take an average, right? Be able to talk about the average value that varies. Remember I gave you, what I give you, like your Social Security number? Does it make sense to talk about the average Social Security number? I don't know what the hell that means. Does it make sense to talk about your, if I look at your cell phones and we look at your, not the area code, but the first three numbers, let's take the average of the first three. Okay, the average is 437.2. That means shit? No, right? So it has to be a quantity, and it has to make sense, like you can calculate the average by adding them all up and dividing by the total number. All right? Now, I'm going to go at this a little bit different here too. I want to show you, see, look, with the bar graph and the pie chart, you didn't need me. You've all seen those before in your life, right? You didn't need me to show you how to make it by hand. What you needed me for was to show you how to get mini-tab to make it really quick and really nice. You remember that whole interpretation thing, right? What did you see? Highest bar, smallest bar, biggest chunk, smallest chunk, right? You need that, okay? Me doing that one by hand, there's nothing really constructive there because the heights of the bars are telling you how many percent, the chunks telling you how many are the percent. Now with a histogram, I am going to do just a little bit of that one by hand. I'm trying to get you a feel for like how you're going to read it and what it's going to show you. And I want to look at this example 1.4. Okay? And it says, what percent of your home state's high school students graduate within 4 years? The No Child Left Behind Act of 2001 used on-time high school graduation rates as one of its monitoring requirements. However, in 2001, most states were not collecting the necessary data to compute these rates accurately. The freshman graduation rate, FGR, counts the number of high school graduates in a given year for a state and divides this number by the number of ninth graders 4 years previously. Now you understand, I'm just reading if you need to know all the background information. This is not helping us at all. Okay? It says, although the FGR can be computed from readily available data, it neglects high school students moving into and out of the state, and may include students that have repeated a grade. Several alternative measures are available that are partially correct for these deficiencies, but some states have been free to choose their own measures, and the resulting rates could differ by more than 10%. In other words, the author's trying to tell you this is all screwed up back then when they were trying to do this. Federal law now requires all states to use a common, more rigorous computation, the adjusted cohort graduation rate that tracks individual students. The use of adjusted cohort graduation rate was first required for 2010-2011, and this finally allowed accurate comparison of the graduation rates among states. Now we're where me and you want to be. Table 1.1, which is on the next page, presents the data for 2013 and 2014, and what you're going to find on page 22 in Table 1.1 is they have states listed, right? And how many states are listed? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's actually 48 here total. So I think there's 47 states. There's somebody been left out. We'll have to finish reading. And the District of Columbia is thrown in, right? I mean, I would expect to be 51, but it looks to me like I counted 16. It says the individuals in the data set are your states. There's 48 of them back there in the table, so obviously we're missing somebody. It says the variable is the percent of the state's high school students who graduate within 4 years by using that whole adjusted cohort graduation rate. The states vary quite a bit on this variable from 61.4% in the District of Columbia to 90.5% in Iowa. It's much easier to see how your state compares with the other states from a graph like a histogram than from a table. In other words, what they're telling me is when I look at it like this, I see a pile of stuff. Right? I've got my states listed, I got the District of Columbia in there, and then I have this percentage that's percentage of one-time graduates. No, I take that back. All 50 of them there. I was off the finger. Right? There's 51 there. There's the 50 states and the District of Columbia, right? So my individuals here, I'd like to keep track of this just a little bit with this problem. Are the 50 states and DC. So there's actually 51 individuals here. And then what was my variable? My variable here is percent. How are they writing this? On time graduates. In other words, the percent of graduates in each state that graduate within 4 years. Right? Let me ask you this. Is this a quantitative or a categorical variable? It's quantitative, right? Because I understand it's a percent. Nobody said, we never said that like you couldn't have a percent as a quantitative variable. This is quantitative. Okay? Now, here's the thing. If we're going to even think about this by hand, what I have to do is I got to look in this table, I got to find the smallest value, and I got to find the largest value. So I'm going to kind of cheat and tell me, they already gave those to me. The District of Columbia was the smallest, and Iowa was the largest. And so when I look at this, what I see is they range from 61.4 District of Columbia to 90.5 in Iowa. And all the rest of them take some value between those two. Everybody understand that, right? So I'm giving you, if you want to think about it, I'm giving you the smallest and the largest. Okay? So now what I need to do is this. I need to take this and I need to divide it up into, I don't want to use the term groups. I need to divide it up into, the book calls them classes. Minitab's going to call them bins. In other words, I need to divide the range up from 61.4 to 90.5 into equal pieces. All right? And I'm going to give you, no way in hell am I going to start at 61.4. I'm going to start a little less than 61.4. I'm going to start somewhere like right? I'm a little less than 61.4 and I'm looking at nice numbers, right? I'm thinking the reasonable thing here to do is to go from 60 to 65, and then from 65 to 70, 70 to 75, 75 to 80, 80 to 85, 85 to 90, 90 to 95. Can I stop? Remember my largest one was 90.5, yes? Now, here's my problem with writing it down like this. I cannot go from 60 to 65 and then start at 65 and go to 70, because what happens if somebody has a value 65? Which one do they fall in? Do they fall in the first one or do they fall in the second one? So what we're really going to look at is this. I'm going to go from 60 Notice all the data are giving me a percentage. What's the decimal place? It's the tenths position, right? So I'm going to go from there to there, from here to there. Everybody following what we're doing? In other words, when I start trying to fit my little guys in here, my individuals in here, they'll fall in only one. $89.9, and then 90 up to, right? So these are what I would call my classes. Like I said, many have going to call them the bins. What did I just do? I just divided the range up from 60 to 95. Are these equal pieces? In other words, if I laid you out a number line here, and I marked off all my little pieces, are the distance between all the little marks the same? Yeah, these are all of equal width, right? That's what I'm thinking about here. Then, once I do all that work, then we have to go back by hand and we have to count how many falls in each one of my classes out of the 51. So I'm going to do this. I'm going to call this column here the count. And I'm going to apologize up front. I'm going to cheat. And I'm going to look what the book did for me here. And what they found is there's 1 there. 1, 5, 9, 11, 23, and 1. Now that would take you some time to go through all 51 of those and count how many fell in each one of the little classes, right? That'd take a while. Everybody agree with that? And then I got a dumb question. If I take this column here and I add that up, what should that add to? Every one of my individuals falls in one and only one of the classes. Everybody follow that, right? So that's what we would have to do. Now, I'm still working by hand here, and I apologize up front. I'm just hoping that when you see the histogram then, you get a feel about, okay, this class has 1, this one has 1, this one has 5, and so on and so forth. So how would I actually make the histogram? The weird thing is it starts just like the bar graph. There's a horizontal, there's an X, there's a vertical, there's a Y. What goes on the X here? Your variable. It is the percent of on-time graduates. What goes on the Y? It's either the count of the number of individuals that fell in the class, or we can do the percent. And in this case, I'm just going to do the count. Sometimes people will write the word frequency there. When they say frequency, they mean count. And I'm going to do it like this. I'm going to do number of states. Yes, I know DC's included, right? Now, my problem this time is, just like with the last time, I have to be able to chop up each axis. Well, how am I going to chop up the X, which is the actual variable you're looking at, or did I already? Didn't I already chop it up? Yep, I'm going to do like this. I'm going to go from, yes, and I am going to label them just like I started that thought. And if you don't mind, right? And now I need to chop up the Y, the number of states. So I'm still going to go back to that little table, that little summary I did. The count ranges from 1 through 23, right? Now, I'm going to give you, right there would be 0, nobody. And then I got to get it past 23. And again, I count really good by 5s. So if I get to 25, that'll take care of my 23. And now what did I have? I had 1 in the first one. There looks like about 1 to me. I had 1 in the second one. How many did I have in the third one? 5. And then the next one I had 9. So you notice I'm making a line just like I did with the bar graph, except there's no gaps here, right? It's not like I have these separate categories because, the range of values actually runs from 60 through 95. And then you would just continue. And this would be my histogram. All right? Anybody follow me? They're all sitting in one. Now, again, nobody's going to do this by hand. Actually, I don't want you to do this by hand. I was hoping me doing this to show you, okay, what's the bars represent here? Well, the bars in this case are representing the number of states that have between, let's say, 60 and 65% of their one-time graduates, and so on and so forth. There are no gaps in the bars of a histogram, unlike a bar graph. Bar graph was made like that. Now, I'll give you, on a bar graph, all the bars are the same width, so our eyes focus on the height. Are all the bars the same width here? Yeah, we made it like that when we made those classes, right? So what should we focus in on? We should focus in on the height, right? The area of the height. Yeah? Because, if you think about it, they're little rectangles here. Okay. Now, before I show you Minitab, a histogram is not a bar graph. A histogram is used to show you the distribution of a quantitative variable. A bar graph is used to show you the distribution of a categorical variable. A bar graph has gaps in it because we made the gaps to separate the actual categories of your categorical variable. The only time a histogram will have gaps in it is if you've made a class and it had 0 individuals in it. That's the only time. All right? That's the only time you would ever have that problem. In a histogram, the only way you're going to have a gap is if you had 0 in that particular class there. Other than that, notice, the bars are going to fit right next to each other. Okay? I got to stop messing around here. Because again, you're not going to make these by hand. So now I got to find a file, the one we just did, because I kind of want to show you that. If I go back here, File, Open, this is example, what was it, 1.4 or something like that? Right, the graduation rate. Now, that's nothing more than that table 1.1 back here, right, on page 22. We want to make a histogram. Now, if you don't believe me that the Minitab is the way to go, maybe not with the bar graph and stuff like that. That wasn't too bad. But here, you see I've got 51 pieces of data, the 50 states, the District of Columbia, right? I want to make a histogram. So I go to Graph, I go to Histogram. Anytime I come here, it's always the same. I just want this very, very simple histogram. Notice this is the one that's highlighted here. I'm going to click OK. It wants to know where's the variable you want to graph. Nobody cares about the first column being the set of individuals. They care about where is the value of your quantitative variable, and it is % of one-time graduation, right? I'm going to click OK. If you don't think this is the right way to go, then there's something wrong with it. If you don't think that's faster and you're doing it by hand, when you go to the house tonight, don't cheat. Actually, look through all 51 of them and see where everybody fell. Okay? Now, here's the thing. You see this x-axis down here? Again, that's the percentage at one time. There's the frequency or the count going up to y. I don't like the way that looks. And what I mean is this. You see this part right here? How the labels are like in the middle of the bars and shit like that? I don't like that. We can fix it. And the way we're going to fix it is like this. I'm going to come right here, and I'm going to put my cursor on the x-axis, and I'm going to double-click. Window pops up. I'm going to go right here, and I'm going to go to Benny. I told you, Minitab thinks of the classes as bins. And I'm going to come right here where it says midpoint, and it's highlighted, right? It's got the little dot in there. It's putting the marks on the midpoint. I want to put them on the cut point. In other words, I want the markings on the side of my bars, and that will do it. If I click OK, what happens to your histogram? So now you notice it's marked, right? 60, and then That must be 62.5, 65, 67.5, 70, right? It picked its own class widths. We didn't pick them like we did by hand. Can I fix that to make it exactly like the book? X-axis, double click, binning. You see here where it says midpoint or cut point positions? What did me and you say to do? 60, 65, 70, 75, 80, 85, 90, 95. Watch what happens. So what it's done is, it's exactly like the one that's on page 23 here, figure 1.5. My class widths are like 5. They go 60, 65, 70, 75, 80, 85, 90, 95. Everybody okay with this, or am I going too fast with the graphic? All right? So here's my question. If I gave you this, and I said, okay, well, so here's the histogram for the distribution of on-time graduation in each state. What about if I asked you, okay, how many of the states have between 85 and 90% of their high school students graduate on time? What bar am I looking at? Between 85 and 90, I'm looking at, how many are we looking at there? Everybody agree it's not 25, but it's a number close to 25? So you got to remember, I'm going to be giving you multiple choice tests. Right? I could give you something that looked like that, and that would be like a typical question I would ask you. Okay, looking at this histogram, okay, how many of the states have between 85 and 90% of their high school graduates on time? Well, if it's a multiple choice test, and I gave you what are you picking? We're going to pick 24, right? Because if I'm looking at that, the closest I get there is 24. In other words, I'm not a complete idiot. I don't give you a question like that and make you pick between 25, 24, 23, and 22. That doesn't seem to be fair, right? So I just want to make sure that you can read. Can you read? In other words, what falls here? What falls here? What about if I ask you, how many of the states have less than 75% of their high school group students graduate on time? Where am I looking less than 75? Is that true? That would be less than 75%. How many are there? I mean, it looks like that's one, and that might be like 5, so I'm looking at, everybody okay with that? So I don't have to ask you about just one particular bar. I can ask you about a group of bars by saying, okay, how many of them were less than 75%? Now I got one more last question here before we move on. What percentage of the states have less than 75% on-time graduates? You just told me there were 7 that had less than 75. What percentage has less than 75? How do you figure that out? How many is in the histogram? So if I asked you for the percentage and not just how many or the count, you would tell me, okay, well, here's the count divided by the total number that's in the histogram. Remember, we had 51 individuals here. So it would be 7 divided by 51, and you'll move the decimal place to the right by multiplying by 100. Everybody okay with that? What'd you get from 7 divided by 51?
13.7%.
13.7. So you ended up with this on your calculator. First off, I want to make sure you can read the histogram and know what it's telling you, right? It's giving you this percent of the individuals in your data set that fall in whatever classes was made for you. Okay? Now, you're going to get practice with this when I give you like homework problems, but I want to make sure you can read. Not make it, you're going to make it with Minitab. Now, question, how are you going to get that out of there and get it in a Word document? The same way you got the bar graph out, right? We're going on. I think the slickest way when you're using a PC is to right-click and send it to Microsoft Word, and it takes all the labels with you. If you do the copy graph, remember you got to do that little paste special spice independent bitmap shit and all that. If you're a Mac person, 2 fingers, copy graph, and it'll take it right in. You put it right in the Word document with a copy and paste like that. All right. Now, we can run into some problems here. I'm going to come back to this in a second. We can run into some problems. And what I mean is, the software is usually pretty good about making choices. And when I say problems, I mean one of the following. Okay? I'm going to give it to you like this. I'm going to give you a couple of names here. One's a skyscraper. And so what I mean by that is when you're looking at your histogram, okay, you got these really 2 big-ass bars, or maybe just 1 big-ass bar, and they're all in 2 classes, right? Well, that's not a good picture of the distribution, okay? So the problem is you have too few classes. And what I mean by too few classes, it's not that you made too few classes, you got too few classes that actually have any individuals fall in them. So the only choice we had in making anything was the class widths, right? So here you want to make class widths. You only got 1 of 2 choices. You either make them smaller or you make them larger. If you have too few classes, you want to make the class widths. You'll make more of them. You'll spread them out. You'll get a better picture of your distribution. Well, what's my other problem? Well, my other problem can be, all right, I've done all my work, and shit, when I'm done, my histogram's a pancake. What it means is, I got all these classes, but I got like 1 or 2 in them. That's not a good picture either. So, what's my problem here? It's just the opposite of the one above. Now I got too many classes. So what's the fix? Make class widths small. Yeah, right. Can't have the same solution on both of them. So what I mean is, if you were using class widths of, let's say, 5, make them 10. 7.5. If you're on the top one here and you've used 5, try 2.5. Or if you use 10, try 5. And you're not going to do it by hand. I'm going to show you in Minitab how I can change the class width to anything I want. All right? So are you okay? Because, look, can I just read to you what the book tells you about all this? The book actually knows what's going to happen between me and you. It says, and I'm on page 23, and I'm on the last paragraph there before apply your knowledge. It says, our eyes respond to the area of the bars in the histogram. Why? Because they're rectangles, they're all of equal width. So what are we concerned about? The height. And so the height is telling me about the area of the bar, right? The taller it is, the more area it is. It says, because the classes are all the same width, area is determined by the height, and all classes are fairly represented. In other words, the height of the bar is telling me what I'm seeing. It says, there's no one right choice of classes in a histogram. Students usually hate that shit. I can't tell you, let's make them 5 all the time. Let's make them 10. No, there's no one right choice. It says too few classes will give a skyscraper. Too many classes will give you the pancake. Neither choice will give a good picture of the shape of the distribution or what you're seeing about your quantitative variable. You must use your judgment in choosing classes to display the shape. Now, you know how screwed that up is? Me and you have been together 2 nights. Right? First night went well, I thought. Tonight we've been together for like an hour and 10 minutes, and your dude standing in front of you and telling you, you know, when you make a histogram, you get to use your judgment about what you want to do to make classes. Usually students in 15-30, they're not overly happy about me telling you, pick it, go for it. Right? But the book knows statistical software will choose the classes for you. Minitab, you saw it chose the classes for me, right, to start with. It says the software's choice is usually a good one. I'm sorry. I know it's Thursday and all, we're about done. No. The software usually makes an excellent choice for the class width. It knows what it's doing, right? It takes that little bit out of our hands. It says, but you can change it if you want. Let's go back. So what me and you're going to come to a little agreement upon here about this, if I get rid of this, just so that we're starting at the beginning, I'm looking at that same data set. If I'm going to make a histogram, I'm going to come to histogram, right? I want a simple one that's already highlighted. I didn't really have to click anything. I need to tell it where the values of the variable is, not the individuals in the data set. That's the first column. And then I go from here. I immediately click OK. And it's going to give me this, and every time I do this, it's going to give it to me. And like I told you, I don't like it where it marks the numbers at the midpoints of the bars. And that's one thing I do not like. So I always, before I even look at anything, I double click there, and I come to binning, and I always choose cut point. Everybody okay with that, right? And then I would click. And at least now, whatever the software made the classes, at least they're marked at the edge of the bar, and it makes it really easy for me to read what's going on here. Now, you notice, it doesn't mark all the little edges of the bar. Can everybody see here that this is actually, we're starting at 60. What's the next mark that's there? Because the next one's 65, right? And then I'm at 67 and a half. And then I'm at 70, and then I'm at 72 and a half, and then I'm at 75, right? In other words, the class widths here are what? You agree? 60, 62 and a half, 65, 67 and a half, 70. That mark right there would be 72 and a half, 75, 77 and a half, and so on and so forth. I just want to make sure you can read it and say, okay, it picked to do 2 and a half. All right? Can I change this to do 5? I want to show you that again. All right? Can I change it and do, instead of letting it pick and do 2 and a half as my class width, in other words, it went from 60, 62 and a half, 65, 67 and a half, and so on. Can I change that? And the answer is, yes, you can. I come here, double click, and anytime you see me change anything about a histogram, it's always in binning. I come down here to the cut point positions or midpoint positions. I mark all that out. I want to go by 5. I'm going to go 60, 65, 70, 75, 80, 85, 90, 90, 95. Now you notice, at least there, it marked every one of them, right? It went 60, 65, and that's the one that's in the book. Everybody okay with that? Now, could I make class width 10? Could I go by 1? I can set that however I want. All right? Now, here's the thing about all this. I didn't say much about this other than can we answer questions about it. Remember I gave you less than 75%, how many, what was the percentage less than 75? How many were between 85 and 90? I want to make sure you can read it, right? So one of our big things about all this is not making that, because I got many tab to make it. And the only thing, normally what I would do is just make sure that it's marked at the cut points at the edges of the bars, because then it's easier to read. I can tell you how many's in there then, all right? I don't usually start changing class widths. And one of the things me and you are going to focus in on really, really big time on Tuesday is this idea here. Examining a histogram. If you don't like the word examining, interpreting. What we're talking about here is now, I already did that for you with the bar graph, yes? When somebody asks you, what do you see, you tell them the biggest one, the smallest one, right? There's way more to this histogram than that. So, here's my thought. I want to give you like a couple steps here. All right? First thought I have is I want to talk about some kind of overall pattern. In other words, I back up and I look at the histogram as a total and I want to think about, okay, like what's my overall, Debbie, where'd they go?
Hey, Mike, that was my fault. Everything should be coming back right now. I hit the wrong button in the room next door. That was totally on me.
We had us scared. We thought we were under attack. Okay, so we're looking for an overall pattern, right? And the other thing is we're looking at striking deviations. Now, what I mean by that is when you're looking at a histogram, and so I'm looking at an overall pattern here. A striking deviation will be that way or that way. In other words, it'll have a much larger value than every other value or have a much smaller one. In case you don't know, and I haven't mentioned it to you, right here's my little x-axis that's always here. That's the small side, that's the large side. I know you guys are looking at it the wrong way, and I'm not good enough to pick small side that way and large side that way, the way you see it. All right? I would have to turn around and do that. I'm not that good. Okay? So, the way I think about it is, when I think about this overall pattern, we're going to give you some guidance. And we always want to talk about shape. We have some favorite shapes. We would like to talk about center. We have a few different ways to talk about the center of your histogram. And then we'd like to talk about the spread. And then, look, I always use the term spread, right? The book's going to talk to you about variability. That means spread. In other words, what I want to know is, as I go from one individual to the next, how's the value of the variable change, right? The spread of the variability. And then these striking deviations, they actually have a name of their own also. And these guys here are called outliers. In other words, they're extreme, right? They're either much larger than everybody else or much smaller than everybody else, right? In other words, I think about them being in the tails here, right? They're kind of stuck out here by themselves, okay? Now, for now, when I think about the center, right, how am I going to talk about the center of your histogram? And I'm going to talk about it being the midpoint. What I'm thinking is half less than this value and half greater. So when I say that I'm looking for I'm looking for a value here where half the observations are smaller and half the observations are larger. What I'm really doing in your histogram is I'm looking for a value on the x-axis that half of the area is to the left of that value and half of the area is to the right. Because remember, what's the area representing? The area is representing your observations, right? So I want about half and half, okay? And then I'm going to write in parentheses here equal areas. Half and half areas. And then the best we can do with a histogram and the spread is, the best you're going to do for me is to give me the smallest and largest value. That's the best you're going to do. Now, we improve upon both of these in Chapter 2, but right now, when we look at a histogram, I'll show you on Tuesday, okay, here's where this 50-50 area point is, and then obviously you can read the smallest and you can read the largest. And then we're going to talk about the shape. Now, before you go, I know my time's up. You guys can start packing your shit. We're ready to go to the house. You got to understand there's two things going on. In this hand, we have our histogram, right? In this hand, you have your distribution, correct? Remember, the histogram is a picture of your distribution. So if I'm going to interpret or examine your histogram, am I actually telling you about your distribution? And the answer is yes. So I will put both of those together for you on Tuesday. I will give you some nice shapes. I'll draw you all kinds of freaking pictures and show you what I can show you here, all right? Everybody be careful going to the house, and we will see you on Tuesday. What do you got? Oh, we can. So did you download the remote desktop?
Hey, Mike.
Yes, sir.
Just wanted to let you know that what happened was that other class ended, and I had clicked on this class to end that class just by total accident, and I apologize profusely for doing that.
No, it's okay. Like I said, I thought we were under attack, man. No, that's cool. There's no problem. Hey, I thought that class started at 6 o'clock.
It did. Tonight was their first night, and they got to know each other a little bit, and then let out until next week.
Ah, nice. All right, man. No, there's no problem.
Okay.
I appreciate you getting us back so fast.
Yeah, I had a panic attack when I did it, because as soon as when the class didn't cut off in the room that I was in, I just freaked a minute.
No, that's all right. I know you're going to have to sit down with me. All right, bud. We'll see you on Tuesday.
All right, have a good weekend.
You too, man.
Don't forget not to come to work on Monday.
I mean, I don't want to say this out loud, but I never come to work on Monday.